Our next unit is going to be on systems of linear equations and linear inequalities. To begin, we first have to understand what a system of linear equations is. A system of linear equations is two or more equations in the same variables. When it says the same variables, that means x and y. Or we can just simply put the two words linear system. The solution to a system of linear equations is an ordered pair, a coordinate, that satisfies each equation. Or, in other words, we have heard of the words making it true for each equation. For the first example, we have a coordinate 5, 2. I'm going to plug that coordinate into both the first and second equation. In the first equation, I'm going to have negative, where x is, I put 5, plus 6 times y, put 2, equals 7. This gives me negative 5 plus 12, and I get 7 equals 7. So the 5, 2 coordinate is the solution to the first equation. Now I need to check the second equation. If I take 3 times x, which is 5, minus 2 times y, which is 2, it should be 11. I get 15 minus 4, and I get 11 equals 11. Because 5, 2 makes both equations true, the answer is yes. It is a solution to the system. It has to make both equations true to be a solution. For this next example, we have the coordinate 3 as my x and negative 6 as my y. If I plug into the first equation, 4 times my x value plus my y, which is negative 6, which should equal 6. I get 12 plus negative 6, and that gives me 6 equals 6. So it makes the first equation true. If I plug it into my second equation, my x value is 3, plus 3 times y, which is negative 6, equals 15. I get 3 plus negative 18, and 3 plus negative 18 is negative 15, which is not equal to positive 15. It does make the first equation true, but it makes the second equation false. Because not both equations are true, the answer is no. It is not a solution to the system of equations. Now, to solve a system by graphing, the solution to a system of equations must lie on the graph of both equations. So for this third example, it wants to know what is the solution to the system. A solution to the system is the point of intersection. So looking at this graph, I have two equations on the x and y axes. The point of intersection is right here. That point is at the x value of 3 and the y value of 4. So the solution to my system is 3, 4. This is the point, x, y, that would satisfy both equations. Now let's try it from a different perspective. Let's try graphing both equations on our own and finding that solution. So there are some steps. First step is we need to write each equation in the form that's easy to graph, which we know as slope intercept form. Step 2, graph both equations in the same coordinate plane, so meaning graph both of them on the same set of axes. Step 3, locate the coordinates of the point of intersection, which is what we just did in example 3. And we're going to write that as a coordinate, x, y. And then step 4, check the coordinates algebraically by substituting the point into both equations to verify it's a solution. And I will show you how to do this in the next example. You are going to want to use graph paper so you can find the point of intersection much easier. So, example 4. I have two equations. My first equation is x plus y equals negative 2. First thing I want to do is I want to get into slope intercept form. So to do so, I'm going to minus the x to the other side, and I get y equals negative x, and it's a negative 2, so I have minus 2. My second equation, I'm going to minus 2x to the other side, so I have negative 3y equals negative 2x minus 9. Then I'm going to divide everything by negative 3. So I have y equals, the double negative makes it a positive 2/3 x, and the double negative makes it a positive 3. Now that I have my two equations, I can graph my y-intercept and count my slope. So for the first equation, my slope is negative 1 over 1. My y-intercept is a negative 2. So starting at negative 2, the slope is negative, so I'm going to go down and then to the right. So down 1, 1 to the right, down 1, 1 to the right. And the more points you plot on your graph, the easier it will be to find the point of intersection. Now I'm going to draw a line through my points. And now I'm going to graph my second equation. So my second equation, my slope is 2/3. My slope is 2/3. My y-intercept is 3. So starting at 3, and my slope is positive, so I'm going to go up and then to the right, up 2, 1, 2, 3 to the right. Or I can go the other direction and go down 2, and then 3 to the left, down 2, 3 to the left, then draw my line. Now that I have both graphs on my same x and y axes, I now need to find the solution. And recall, the solution is the point of intersection, which is right here. So my solution on the x-axis, I'm at negative 3. On the y-axis, I'm at 1. So my solution to the system is negative 3, 1. It's the point of intersection. The last step was to check your solution. So the first thing, we solved for slope intercept form, then we graphed both equations, we located the solution, the point of intersection. So now for step 4, I'm going to make sure it works in both equations. So my x value is negative 3, plus y is 1. That gives me negative 2, which equals negative 2. The first equation works. My second equation, 2 times x minus 3 times y should equal negative 9. So I get negative 6 minus 3, and I get negative 9 equals negative 9. It works. Therefore, I know that my solution, negative 3, 1, is correct. And that concludes